Good morning, Townview. Welcome back to Chemistry Online.
So today we're going to be talking about acids and bases. So top of your page, let's go ahead and write that down, acids and bases. So acids and bases. And today our focus is going to be on nomenclature. Can anyone tell me what nomenclature is? It's the rules of naming. Good. So nomenclature, that's going to be the rules of naming. So today we're talking about acids and bases, specifically the nomenclature, which means the rules of naming acids and bases. Now this PowerPoint used to be really long. What I did was I condensed it. So here's the condensed version of our PowerPoint. So first thing we're going to do is I'm going to have you guys write all of this, everything you see in the red bracket. Let's go ahead and write that down. And then in a couple minutes we will discuss. All right, so now that everybody's got this written out, let's go ahead and discuss. So there are two types of acids that you guys are going to come across. The first type are going to be the ones that have no oxygen in them. And these we're going to be referring to as binary acids. What does binary mean? It means two. So binary acids, these are typically made of two things. Example is going to be HCl or HBr or HI. So it says that the anion ends in IDE, so hydrogen chloride, so chloride ends in IDE. Basically all of the nonmetals end in IDE when they're bonded with something: nitride, oxide, sulfide, fluoride, chloride, bromide, iodide. So if they end in IDE, what we do is we start by writing out the hydro, and then we take the root of the anion. So for chlorine, we take chlor, and then we add an IC to it, and then the word acid. So over here, HCl, what do we call it? Hydrochloric acid. Good. The next one is going to be HBr. It has no oxygens in it, so we start with the word hydro, and then we bring out the BROM, and then this ends up being hydrobromic acid. What about HI? What do y'all think? It becomes hydroiodic acid. So there, but the two main ones you want to know are sulfur. So H2S, if you had to guess, what do you think that one becomes? Acid is what most people would say. So for sulfur, we just use the whole word. So it's going to be sulfur and then IC, so sulfuric. And then another one is going to be phosphorus, so H3P. So for phosphorus, we do the same thing. We just use the whole word. So it becomes hydrophosphoric. So those are the two exceptions. Everything else, we just take the root. For sulfur and for phosphorus, we just use the word and we add IC to it. Why? Because it sounds better, I think. Kind of. All right, let's move on. So that's the main type of acid. These are the easy ones. Nobody ever misses these. The ones where students typically make mistakes are the ones that include oxygen. So if they include oxygen, that means that it's got a polyatomic ion in it. We also call them tertiary, but their most common name is going to be oxyacid. So ternary acid, tertiary acid, or oxyacid. Why do we call them oxyacids? Oxygens, good. Man, look at y'all listening. All right. Shh. That's why he's on the wall, though. All right. Shh. Let's keep going. So let's take a look at our polyatomic ions. Everybody grab your polyatomic ion sheet. Everybody grab your polyatomic ion sheet.
What is it called?
The polyatomic ion sheet. All right, so with the exception of ammonium, what does everything on this list end in? There are two main ones. What are the endings for these? All right, so we have 8 and we have ite. So for polyatomic ions, those are the two most common endings, 8 and ite. Those are the ones that you're going to need to know for naming. So if we had something that ends in 8, for example, carbonate. So what's the formula for carbonate? What's the charge? So to balance this, we're going to have to put 2 hydrogens. So the acid is H2CO3, okay? And it ends in ATE. So what do we do to its name? So for carbonate, we're going to put carbon over here. We get rid of the ATE, carbonic acid. All right, let's do another one. Let's do nitrate. So what's the formula for nitrate? What's the charge? And then how many hydrogens? 1 hydrogen to balance out this negative charge. And then what are we going to call nitrate? All right, so we get rid of the ATE, and then we put in the IC at the end. So this becomes what? It becomes nitric acid. Okay? So if it ends in ATE, we get rid of the ATE, and we put in the IC. Now let's take a look at the other type. The other type are going to be the ITEs. So let's all look at chlorite. What's the formula for chlorite? What's the charge? So how many hydrogens? 1 hydrogen. There's our formula right there. So chlorite in its acidic form, what's it going to be called? Chlorous acid. All right, let's do another one. So nitrite. What's the formula for nitrite? NO2, what's the charge? All right, so it needs 1 hydrogen to balance it out. And then what are we going to call this? Nitrous. Just like Fast and Furious, yes. Nitrous. All right. Shh. I appreciate it. I like the connections. All right, so before we move on, I got a quick story for you guys. So when I came to the U.S. a long, long time ago, I always associated pizza with being the best American food. My mom, all she ever cooked for us was rice and chicken, and all I ever wanted to eat was pizza. You know what I'm talking about? So when they served pizza in the cafeteria, that was my favorite day. So this is one day, first grade, I go into the cafeteria and I get my pizza, and I take a big bite of my pizza, and then I get this long, nasty hair inside of my pizza. Okay? Is that a cool story? All right, anybody got a similar story to that? All right, go ahead. What you got? Let me pause this video before I get sued. All right, so how does this relate? Everybody, let's go ahead. All right, please relax. So how does this relate? On your page, I'd like you to write, in the cafeteria, you ate something icky. This is really, really important. So the association is going to be ATE turns into what? Ick. So 8 turns into what? Ick. You only need to memorize one of them to know the other one. So if 8 turns into ick and you're looking at something that ends in OUS, what was that before? That would be ite. That's cool, right? So the only one you need to remember is 8. So 8 turns into ick. So in the cafeteria, you ate something icky. Now, if you know 8 and ick are associated, then you're going to know OUS is associated with ITE. So you just need to memorize one. Another thing my student came up with earlier today was he bite something that was delicious. So if you like that one, so you ate something icky or you bit something delicious, but that's on you. You can write. All right, let's make sure our computers are up. I don't like that. We're locked in here. All right, let's move on. Okay, so back to acid nomenclature. So one thing I need y'all to know about acids today, we're going to spend an entire lesson learning about acids. What I need y'all to know about them today is their formulas typically begin with what? Their formulas begin with hydrogen. You don't need to write down any of the examples. Let's go ahead and move on. Now, everything on this slide was already written down from the front slide, so there's nothing you need to write from here. But just know, if it does not contain an oxygen, it has the word hydro. So we only use the word hydro when we're describing a binary acid or an acid that does not contain an oxygen. So that's when you see the word hydro. Let's keep going. Now, if it does contain an oxygen, you're going to see two types. You're going to see the ate and the ite. Ate turns into ic, and ite turns into ous. Any questions on this? All right, let's muévale. So let's go ahead and work out these examples. I'm going to give you guys 4 laps to go through all of these. So real quick, I want to see this. Go ahead and go through these real quick. Let's go ahead and run through these real quick. So the first one is what? Hydroiodic acid. All right, so here's how we're solving these. First thing we want to do is we want to look at it. We want to say, is this an oxyacid or a binary? So for the first one, it was binary. That's why we use the word hydro. And then we add the IC to the end of iodine. Now for the next one, same thing. Is this binary or an oxyacid? It's binary, so we're going to start with hydro. And just know this is one word. I separate them, but they should be one word. So hydro and then chlorine. We're going to get rid of the INE and we're going to bring in the IC. So hydrochloric acid. All right, let's look at the next one. Is this binary or oxyacid? It's an oxyacid. Now, anytime you see an oxyacid, first thing you want to do is you want to write down you ate something what? You ate something icky. Now, let's find PO4. What is PO4 called? Okay, phosphate. So phosphate is going to turn into what? So phosphate turns into phosphoric acid. And I know this is one of those exceptions where you can't just throw letters onto it, but you know, you're going to know that phosphate turns into phosphoric. Just from the practice, you're going to know. And in a few slides, we're going to compare all the phosphorus containing acids. All right, next one, is this a binary or an oxyacid? Oxyacid, and then what is the polyatomic ion? Nitrate. So nitrate is going to turn into what? Nitric acid. All right, last one. Is this an oxyacid or a binary? So it's not an oxyacid. It's not a binary, but we treat it like a binary. So it's going to be hydro, and then what's CN? Cyanide. Cyanide turns into what? I miswrote that. So cyanic acid. Hydrocyanic acid. It's a cool name, right? All right, let's go ahead and move on. Okay, so now we're going to discuss going from name to formula. Ignore all this. Don't be looking at it. Stop looking. That's because you don't listen. All right, stop looking. Stop. Okay, let's take a look at these examples. So the first one is hydroiodic acid. So because it's got the term hydro, what does that mean? It's binary. It's 2 elements. It's hydrogen and something else. And then we could see iodic. What element is that? Iodine. What's the charge on iodine? -1. How many hydrogens will we need? 1 hydrogen. So HI, that's our formula. Just know the charges are not part of the formula. We only use them to figure out how many hydrogens we need. All right, next one is phosphoric acid. Is this one binary? No. So this is where we're going to need the 8 turns into ic. So over here we have ic. So what is this? That's going to be phosphate. What's the formula for phosphate? What's the charge? So how many hydrogens do we need? So H3PO4. Now that's easy, right? All right, let's go ahead and move on. So let's go ahead and work these out real quick. All right, don't sit. All right, let's keep going. So looking at this first one, it says hydrobromic acid. So when we see hydro, what are we looking at? We're looking at a binary, and this one's got bromic. What is bromic? That's just Br. What's the charge on bromine? -1, how many hydrogens? All right, so there's our formula. Just know the -1 is not part of the formula. This is neutral. All right, next one is nitrous. So as soon as we get to the oxyacids, we're going to bring out the ATE, something icky. So this one ends in OUS. So is this one an 8? No. So OUS is what? Ite. So nitrous is going to be what? Nitrite. What's the formula? NO2. What's the charge? -1. So how many hydrogens? 1 hydrogen. There's our formula. All right, next one is carbonic acid. So carbonic, what are we looking at here? Carbonate. What's the formula? CO3. What's the charge? How many hydrogens? Man, that's easy, right? All right, next one is phosphoric. What are we looking at here? Phosphate. What's the formula? What's the charge? How many hydrogens? All right, and then there's your formula right there. Hands up if you feel good about this. All right, there are 2 questions on the ACP about this. So there are 2 stoichiometry questions, and there are 2 on acid nomenclature. So I want y'all to get these. Let's keep going. All right, so here's our next set of examples. I want you to do 4, 5, and 6 before you do 1, 2, and 3. So do these first. I'm going to give you guys 5 laps. All right, let's go through these real quick. So the first one I'm going to go over is number 4. So is this one binary? No, it's not. So we're going to find SO4. SO4 is what? Sulfate. And then up here I'm going to write it out. So ATE turns into IC. So sulfate turns into what? Sulfuric acid. Good. All right, so SO3 is what? Sulfite. Ite turns into what? So this one is going to be sulfurous acid. All right, the last one. What's the question? It's just that's how they chose to name to do sulfur, and it just sounds better. So the question is the question why is it sulfuric, not sulfic?
No, she's asking why instead of IC you added OUS.
Because so SO4 is sulfate, right? And then SO3 is sulfite. Now the only way to differentiate between these two, the one that's got 3 oxygens versus the one that's got 4 oxygens, is the difference in naming. So sulfuric because it's got more oxygens, sulfurous because it's got fewer oxygens. Does that make sense? All right, now let's look at the last one. So the last one is a binary. So what does it start with? Hydro. And then what's sulfur going to turn into? Sulfuric, you're right. Sulfuric acid. Hydrosulfuric acid. All right, now let's come over here to the top. So PO4 is what? Phosphate turns into what? Phosphoric acid. Phosphoric acid. And then PO3 is one that they've tested on previously. And just so you understand why, let's all look at our periodic table. Everybody find chlorate. What's the formula for chlorate? ClO3. What's the formula for chlorite? ClO2. Look at nitrate. What's the formula for nitrate? NO3. What's nitrite? And then what's sulfate? And then what's sulfite? So what's the difference between the 8s and the ites? So the ites are always going to have 1 less oxygen. So it's the less oxidized one. It's the one that has fewer oxygens. Yeah. It's in the video. But that's the difference. You don't need to remember that because you can just look at the periodic table and figure it out. So PO3 has been tested in the past, even though it's not on your formula sheet, just because they want you to figure it out. And the answer for this one is what? Phosphorus, OUS. Not phosphorus, phosphorus acid. And then the last one is going to be what? hydrophosphoric acid. So the only difference between the first one and the last one is the term hydro. So just keep in mind that's important. So hydro tells us that we're looking at binaries. Same thing over here. So hydrosulfuric versus sulfuric. Those are very different things. And the word hydro makes the difference.
Wait, so why do we add hydro to the last one instead of the other one?
Because this one's a binary. So if it doesn't have any oxygens in the formula, it's a binary, which means you use the word hydro. If it has oxygens, that's the ones that don't have the word hydro. All right, any questions on this? Okay, final slide. So this one is the final slide. I just have to write some stuff. So the last thing we're going to discuss is naming bases. And I don't have a slide for it, so we're just going to put it right here. All right, final slide. Let's go. Okay, so first thing I want y'all to know about bases is the most common base that you guys are going to see over and over is ammonia. Anybody know the formula for ammonia? It's NH3. So ammonia is NH3. Y'all remember this from biology. Now, what's the polyatomic ion that you've been using all year? That's ammonium. And they're different. So NH4 plus. These are different. So this is a very common base. You're going to see it written out in questions all the time. And I just want y'all to know what it is. It's a base. It's different from ammonium, which is a polyatomic ion. It's just... It's the one that's in a lot of cleaners. Yes, bathroom cleaners. Anyway, so first thing I wanted to discuss with regard to bases, I want y'all to know that ammonia is a base, and you're going to hear about it a lot. Now, the next thing we're going to discuss about bases is I want y'all to know how bases work. So if we have hydrogen and we add hydroxide to it, what are we going to produce? We're going to produce H2O. That's just the thing I want y'all to know. So H plus and then OH minus, when we combine those, we produce neutral H2O. All right, now we're going to get into the actual naming. For naming, it's just, so for naming, we're just going to use ionic rules. Ionic nomenclature rules. And what do ionic nomenclature rules tell us? They say name the metal, and then for bases, we're always going to have a hydroxide. So first you name the metal, and then you name the hydroxide. And we don't ever change the name on the hydroxide. So you already know how to do this, but now you're going to actually know that you're doing it right. So here's our first example, NaOH. What's this called? What about KOH? What about LiOH? What about CaOH2? Calcium hydroxide. Do we add any dis or tris or tetras? No. We use ionic rules, so numbers don't matter here. Okay? Last one, MgOH. All right, good. Y'all are ready to test.
If you don't know how to do chemistry, hit that subscribe button. Let's go!